All right, so first we'll kind of go over this first line of untar data and kind of what it's doing. So it has a similar functionality as to fastai version 1 in the sense of we can use it with the fastai datasets to grab anything. But with fastai 2, we can pass in an extract function and use other non-tar or zip-based files, which also untar data now natively supports zips as well. So if we look here at the source code, how do we tell that? All right, so if we follow untar data, we can eventually see that we will go and do a download data. And so if we go and look at what download data gives us, we can see that we get a download. Actually, I'm totally blanking right now. Where did we figure out the zip bit? Um, File extract. Thank you. Yes, thank you. So as I was mentioning, the default extract function is this file extract. And so if we go look at what file extract is doing, it'll check to make sure if the file name has either a gzip extension or if it has a zip extension. And then it'll go through and extract whatever we want from either one. What that allows you to do is, so first, zip files are now natively supported, but then you can pass whatever sort of extract function you might want to use. So if we look at the file extract again and look at how we're doing with the zip file, we could try and make our own extract function. So if we do extract zip, pass in a file name and a destination, we could do zip file.zip file, fname extract all destination. And this is all that untar data is really doing, and then it'll return the path of wherever that was stored to. So that's just kind of one way that you can customize and use fastai in ways that weren't too supported back in the day. Sure. Yep. So let's go take a look at what that actually does. So if we go and look at what we're doing right now, so we're calling vision.all, right? So we're going to go into the actual main library here for a bit. And if we look at vision, there's an all module. And so in each of these .alls, they have a certain specific amount of modules that'll be called from fastai. And so here, anything with the dot, is in the native library or the native directory we're in right now. And I'll zoom this in a little bit. So we'll call, augment core and everything from the vision section, and then whatever else we need from the other sections. And each one of those sections also has this, dot all, as you can see with models and callback. And so the library is built to where you just call the dot all and it grabs all the related files to whatever you're working with. Yep, yep. Right here, you mean, or the? No, it doesn't. So you have to do the dot all because it's actually a specific module. So if we look at what the initializer does, because we can do vision, you notice there's nothing here yet. Eventually we'll get to that point, but right now, as they're still, anxious about if anything's going to change, for right now, the uh, dunder and its don't really have anything. So, yes, I should be. I am. Absolutely. All right, so let's go to this next part now. So sure. Yep, exactly. Absolutely. So now we have this is cat, and as we learned, this is just is it a cat or not? So it's this sort of binary problem that we're working with, and uh, thank you, thank you. Yeah, I haven't watched all of the lecture yet, so I'm working my way there. So we'll get through it together. Yep. So that's exactly what this is doing. So essentially, if we, for instance, just copy paste this particular path just from our images, and we'll go over what get image files and everything does in a moment. And we grab the zero position of this string. I believe this is how this is going to work. No, maybe not. Yes, the red. Sure. So let's go ahead and do. Yep, we'll just get the first one. Um, so for those that aren't aware, get image files will just go through and grab any sort of file names that have extensions related to images. Now, it's upper level, what it actually is calling is get files, where you can pass in a path and the extension that you want to look at, and you can go through recursion or not, and any folders you want to look at. So that's what get image files is really doing in the background, and we can see this if we do move these guys over a little bit, and you can see that it's just calling the get files. So in the new library, we're still using Pillow, and this library is sort of transformation based in the sense of everything's going to have a .create function if we're dealing with items. There's going to be what are called encodes and decodes and all this other crazy stuff that we'll be seeing later on in the course. But for now, know that if it has create, that means we're going to be creating some sort of item or object of some degree. And so if we just do image here, which is just a regular pillow image, there's no real fastai nonsense done in the main bits, because we can actually look at the PIL image source code. And you'll notice that doesn't really tell us much. It just says PIL image inherits from PIL base and just pass in any arguments. So let's go look at PIL base. And now we get something a bit more what we're used to. I'll go ahead and copy this over here for some readability. Also, if we don't want to go too deep into this right away, let me know, and we can just keep going down. But otherwise, if there's no complaints, I'll keep going. Hmm. Uh, yeah, I think I know what you're trying to say. Yeah, so like let's do it with I'm yep, so there's the example. Um, Thank you for pointing that out. So if we kind of look at this PIL image, and then I promise after we explore this PIL image, we'll actually go into image data loaders as a whole. Um, you can see that we're basically calling PIL image functions, and we type check to see if it's a few different inputs. And if so, then we operate a few different functions on them. But eventually we call this load image function that goes back to the original class. And if we look at load image, opens and loads a PIL image and converts it into a mode. So that's all we're doing at the end of the day. Uh, all this is doing first is getting the data in a way for us to call uh, image.open. So are there any questions about that? Because this is kind of different than how V1 looked. in terms of image types and data types, because every single bit of data that you want to bring in, be it custom, will follow this sort of format where we have this create function that says how you want to build it, and then all of them will have this show function as well, where when we call, show batch, how is it going to work? So, and how is fastai going to know this is how I want my particular data to be read and viewed? Yep, it's pillow. Uh, yeah, let's go talk about those guys now. So, as Jeremy kind of mentioned, image data loaders is the highest level in terms of the API and what we can sort of do. And I'm sure, as most of you are aware, there's a big name change now. Instead of data bunch, it's now data loaders. The reason for that is you can have an infinite number of data loaders in any one set of data loader. Flip that. Any number of data loader in data loaders. So we can have infinite test sets essentially. So that's kind of why there was this name change. And if we look at what image data loaders is actually doing, for the first two, if we call a from folder or a from path function, we're using the mid-level API. We're using the data block. And then as we slowly go back down, you'll find that they all trace back to the mid-level data block. Nope, that's the low level actually. Well, okay. Yeah, it is semantics. If Jeremy wants to, yeah, if Jeremy and them are calling it high level, then we'll call it high level. I call it the mid level, but that's okay. This is sort of the data block, which can, I guess, be viewed as a high level as well. Um, Jeremy will sort of, I believe, go more into this in the next lesson when we start talking about the custom data. I would not be surprised if he begins going over that. But you'll notice that it builds off of building blocks, because we have, like, this image block and this category block. And we have, get items, splitter, and all these weird bits that, when you look at the names, kind of look familiar to the V1 sort of, um, image list that we used. So let's look at this particular data block, which is streamed, or which is grabbed just exactly from name func. Actually, I'll grab the exact one from name func, which comes from path func, which is this one right here. Sure. So the vocab, because you can call it category with vocab, right? Is that what your question was? So you can pass in a specific vocabulary to use. Um, so if you have, say, some items showing up in your validation set that don't show up in your training set, you can pass in a vocabulary that will go ahead and adjust the model accordingly. So even though it didn't show up in your training data, your model is still prepared for it to show up. Does that sort of make sense? Cool. Uh, so this is what we were looking at, right? So we have this data block where we have all these different options. So let's try and plug point to point what's going on. So we pass in a path. This path gets called from this dot data block, which I'll show you what that looks like at the end. For now, we'll just keep moving on. We have this get uh, image files path, which if we look at image data loaders, I actually want to point to where that is going in. So I'll go ahead and keep this out here. So as we follow, it's our file names. And so this will tag into also from our data block, which this is what will actually make everything into a data loader. The data block itself holds no information besides how we want everything to be done. It doesn't have any items in it. It doesn't have any data in it. It's sort of just a list of directions that we want our data to be prepared in. Does that make sense? Exactly. Hmm. Yep. So you can kind of let's read it from the top down. So blocks is how I expect my input and my output. So here we're expecting an image as my input, and my Ys are going to be a category. All right, after I get, these items, this collection of items, I'll want to split them. And so we'll split them randomly by our valid percent that we pass in and some seed for reproducibility. When we go ahead and get all of our files, we're going to need a way to extract it. And so this is where our label function comes into play. It gets passed into getY. And then any item transforms we want to apply go into item, batch goes into batch. Originally, this wasn't part of the library, but uh, you can. It's a part of it now for a data block summary to help with debugging, uh, which will probably show up in the next lesson. If not, th so some key differences between item transforms and batch transforms, and this will probably answer your question. So you always need an item transform if you have images of different sizes. If you leave this blank, and for instance, with how ours currently is right now, all the images are different sizes, we're not going to be able to make a batch because batches expect everything to be the same size. So at the very least, if nothing else, I need a resize function here to resize everything. Hence why we have the item transforms as resize. And a key difference between item and batch, the reason why that exists is item transforms are run on the CPU and batch transforms are run on the GPU. Absolutely. So a batch transform can honestly be anything. So I could run, resize again, 224, or there's a re exactly. Now there's some, modifications that might be needed for custom transforms and stuff because, batches are applied on batches, items are applied on items, but as a whole, you can kind of think of them as the same. Just make sure that when you're working with your data, always have some sort of resize on your item transform so everything is the same size. Hmm. I'll show you an example right now. So let's do batch trans. Exactly. So let's try getting rid of the resize and see what happens if we try showing a batch. Nope, we're good. So we get an oh no, sizes of tentures mismatch in dimension 0. What does that mean? It means that we didn't resize everything. And as I was saying with the batches, it expects everything to be the same size. Yes, exactly. Exactly. An example of this in the yeah, absolutely, you could use both. Sure. You can you can use any sort of transform in the item transform and the batch transforms. Um, there's like rotate, flip. Um, there's it can, yes. This is why we have so much data augmentation. It lets us do more with less samples and less training, because everything is being presented in a radically different way. Now, when we go to the validation set, the only transforms that are being applied is any sort of normalization and resizing. Uh, Anything that has major augmentation is sort of reserved for the training set. And yeah, and I think this is the code that it describes. Is it in this chapter? Okay. Yeah, I think it's chapter 2 or chapter 3. Um, but this is sort of the technique he's describing. So in the yeah, so like let's see if we can get an example of it that shows up. I think as most of these are bigger images, we might not see that behavior yet, but let me try throwing in some rotate. Ah, what did I miss? Ah, rotate should be on the batch. I'm not 100% sure if it actually let me do that. I'll be honest, I haven't played around with the high level API a whole lot, so this will be new for me as well. But can we get the behavior to show up? I don't think we can right away. The easiest way, though, to kind of look at that is if we look at resize. So we can see in the method it calls crop, and the pad mode is reflection. So that's the behavior that he's talking about. So any other questions related to that, or anything that kind of needs further explanation? I I mean, you could. Um, it would be something along the lines of exactly. It would be something along the lines of Bayesian optimization, where it's something that you sort of do exploratory, honestly, exploratory analysis by trying various items, by trying various seeds. I was about to talk about that actually. So that's a great point, because that's another thing we have to consider. It's how are you overfitting? And, test sets can kind of deal with that in some ways, but in other times, set, modifying the seed to get a higher validation accuracy is kind of overfitting your model a little bit when you think about it, because you're trying to figure out what the best random split percentage is that my model has the easiest time learning. In a way, but it's, that's another way to think about it. Yep. Um, it's great if you're wanting to show like a reproducible example of something, but um, I think even Jerry mentioned this last year. Usually you want the randomness because the random behavior will show you something interesting sometimes. No, so cross validation I have implemented in the library. I can bring that notebook if you'd like, but it's the splits operate in. We can kind of look at that. So one example is we have this random splitter, which is just split by random percent. And you can see that it creates a function that splits items, which is a bunch of items essentially, between train and validation with a split with a percentage. So it only works on two. Now you can have multiple training and validation sets and do cross validation, but that's going to be more on the lower level API. So like to give you a peek of what that looks like, I don't want to overwhelm anyone too quickly, but since it was asked, um, So an example of what cross-validation could look like for for it would be something like this. So we're using the data sets, which is the low level, and essentially what we have going on is I have these variety of splits that I just pass into my model, and I create separate data sets for each. Now, what you could also do is create one data set that you do a whole bunch of splits off of and just define different splits as you go along. But, it's just kind of show it's not built in the library, but it can be done. The library gives you the freedom. Exactly. So if I, it could, absolutely. So like, let's kind of look at what random splitter will actually do. So we have our get image files that we called earlier, right? So let's go ahead and grab all the file names. Now, random splitter is a function that we can just pass in these parameters. So we could say like, val percent is 0.2. Now I can do splitter file names. And here we have a list of indexes of what's in my training and what's in my validation. So all of these splitters that we're using will do exactly this. It'll separate it into these two arrays. And if you're confused as to what the heck this is, because it looks very different to you, this is an L. So I could have 1, 2, 3, and it's an L array. Um, it's something that Jeremy and them kind of came up with. It's in the code walkthroughs that Jeremy discusses, but don't be surprised if you see this random weird looking array pop up. Yes, sorry, yes. Yeah, so like 3 is the total number of items in there. So we have, 5,900 that we're expecting in the training and 1,400 in the validation for this particular split. Yep, exactly. And one thing that you can do with V2 is, so you know how I mentioned we can have unlimited data sets very briefly? So what that actually means, if I go over to, say, here, we can kind of understand what I'm sort of talking about, is you can see that I pass in when we call get preds here. So what this will call is the data loaders that we have, because if we look at our data loaders here, so we have our DLS, right? I can index into them to get access to them. And the whole point of that is I could have DLS 7 if I had, 7 data loaders on this one group. And so I can have like DLS3 be what I want my test data to be that, my cross validation's all going to be based off of. And so we can call, get preds with either an ID to get to the second index, or we could also do something like learn.get preds dl equals my second data loader that I made, and it'll run it on that data loader specifically. Yep. So yes, that's another thing that's I really love about the library now, because it makes everything a lot easier. Yeah, you'd have 7 lists, so you'd have 7 data loaders. Uh, so what you would wind up doing is adjusting the fit functions and adjusting how you want to train. So, like, let me go ahead and make a learner real quick. So if we do, yeah, actually, I'm wrong there. So what that actually allows you to do is this is at the lowest level. So this is at the data sets level. And what you can do after you have one general data set with these splits is you can make various data loaders that you train off of, and you just call occasionally when you want to train on each one. Um, we can go into the low level and I can show what that looks like if we want, but we can also save that for a later date whenever we get a look at it. In Yeah, uh, so the later, yeah, so I think I hear someone echoing real quick, but I don't quite know who that is. Is it gone? Looks like it's gone. So did we decide that we wanted to do low level or not today? Yeah, absolutely. Ah, yes. Good point. So let's go through and actually walk through CNN Learner. Because CNN Learner has basically this giant function, but it all goes back to this base learner class. So this is what it really looks like. And let's sort of go into what's going on here. So we have this model meta. Yeah, yeah. So would you rather us go through the notebook first? Sure. Yeah, and when it's done, I'll just record it to my, or I'll just upload it to my YouTube channel, since it's easy to do that. And I'll just point to it in the general discussion chat for the time being. So if we're just going from a top down, we're gonna do this create CNN learner, or CNN learner, sorry, where we pass in the data loaders that we made earlier, some model architecture we want to use, which in this case is a ResNet 34, and some metrics. Now, CNN Learner is specifically used for transfer learning cases, um, where we know that we want to use pre-trained weights, or we want to, at the very least, have if you're familiar with the old course, we have or actually even right now, the fine tuning where we do differential learning rates. There we go. So now that we have this learner, which, if we want to explore the architecture, we can do learn.model and we can see that the ResNet's living in there. Um, we can call this learn fine tune function. And we can see that even though we passed 1 in the example code right here, it fit for 2 epochs. Why is that a thing? Well, if we go take a look at what the source code tells us, and just so it's readable, I will go ahead and chuck it over here for us. We can see that first we call freeze, and freeze will go ahead and say that everything but that last little layer that we're trying to train, make sure that it can't be trained. So their weights are frozen, is what that's called. We'll call fit 1 cycle, where we train with the 1 cycle policy, for this freeze epochs, which defaults to 1. So this is where our other random epoch comes into play. And for those that might be confused by that, epoch is just running through your data set completely once. So unfreeze will, if you just call unfreeze like it is right now, it will unfreeze everything. So let's take a look at that. If we do freeze, and this was brought up in the forums, but if we do learn.summary, which will sort of tell us the model itself and what it's looking like in all the layer sizes, the bit I want you to focus on is right here. We have total trainable parameters of about 500,000, and non-trainable is at about 21 million. So what that means is all but this last linear layer and this head of the model is what's being trained on. So the head is everything after this, or including this adaptive average pool 2D. So another thing that CNN Learner will do is generate a head for you that has had, empirical research by Jeremy and others to try and figure out what else we can do besides just that one linear layer that we chuck in. And so this is sort of what they came up with. Other way around. So so we freeze the encoder. So we freeze the base architecture. So we're freezing the ResNet up until that very last layer and keeping their weights the same and training that last little head of the model. Yep. And we don't actually adjust those until we call that unfreeze. Not quite. So if we look at, say, like 0, -1, this will just show us what the last little block of ResNet is. Normally, there would be a linear layer here after this last basic block that has like in features 512, out features of 1,000 for ResNet's 1,000 classes. We throw that layer out and create our own head essentially that we use, and that's what this whole thing is right here. Yeah. So if we do that, that's what the previous head looked like. So we had this adaptive average pool layer and this linear layer. And so we took this and turned it into this big old head. Well, I learned quite a bit from that. Wow. Thank you very much, guys. No, that is the CNN learner. That is this function right here. Um, this is all about training. So after we call CNN learner, our model is essentially built. So yep, yep. And you can see that right here. So this just grabs the last layer group's last layer. We now have 512 with 2 because we have, true or false. Yep, cats and dogs. So is there any more questions on fine tune or you can kind of see that it calls fit one cycle, adjusts the learning rate a bit, and halves it before we unfreeze and fit some more. I think it's just because it's the top of the model. Yeah. So when I think of neural net models and their architectures, with sort of thinking about it from a fastai perspective, I think of the first layer as the bottom of a tree, and then as you build up to the top, you have sort of your final output. Exactly. Yep. Absolutely. It's all PyTorch. So any sort of PyTorch model you want to bring in, you can use. The multi-head example, I have an example of that in the Practical Deep Learning for Coders 2.0 or the Walk with Fast AI 2 repo. But yeah, it's all PyTorch at the end of the day. And we just have wrappers that lets us do these nifty sort of ideas. Sure. It's used. I think we're gonna use it next week. It's not used here because if you notice, we have a base learning rate, so we just use the default. But absolutely, we could call LR find, which this is all you have to do now. You don't have to do that recorder dot plot, and it'll still go through and find and try out various learning rates for you to use. So we'll let that run, and you'll notice it's the exact same as V1. Yes. Uh, Once this is done training, we'll see that. But yes, it is. Um, and obviously, take it with a grain of salt if you notice you have a very weird learning rate graph. But why I can't 100% say, my best recommendation would just be look at the source code. Um, yeah. All right. Sure. So the rule of thumb with the learning rate finder is generally you want the steepest slope and you want somewhere in that range. So if we look at this 005, uh, I believe that's 1 in or 5 in egg 3, right? Okay. And so that's about here, which is, this. Yeah. Yes. Sorry. They're backwards. Yes. Always confuses me. So it's about right here, which is roughly the middle of this, which is where your steepest slope is going to be. Yeah. Yeah. I would say at the end of the day, it is just a suggestion. They're trying to give us something that we can work off of empirically to try and understand and read this graph a little better. But at the end of the day, it is a suggestion. Yeah. Gotcha. You you probably could if you passed it in like as a slice or something, where we do the differential and we have, a maximum and a minimum. Uh, you know, I think it's good if you're not sure. I usually try and pick somewhere in the middle, but that's just, as you play around with it, you figure out behaviors. Yep. Yeah. We'll compare and contrast. That, that's actually a good point. Yeah, because usually when you call CNN Learner, it actually is added on to the end of it if you pre-trained. Got it. Thank you. So it's there if we try and run it twice and want to basically run it again. because otherwise you're not going to be freezing and unfreezing. You'll just be unfreezing an already unfrozen model. So it training. So like what I mean by that is, so we have learn right now, right? So now my model is completely unfrozen. That essentially does nothing. That second unfreeze. So if we wanted to go and do that, we would need that freeze again. So this is kind of back to the lesson one transfer learning example from pets, even from a few years ago with the third version of the course. So uh, Sylvan, you can tell me if I'm wrong here, but I think this is more of a sort of comfort function to sort of take 7 lines of code or 5 lines of code and bring it into one. Because the technique is still the same, where we train a frozen model for, a number of epochs at a particular learning rate, and then we unfreeze, increase, or divide the learning rate by some factor, and then train again after it's unfrozen. And so this way, instead of having all those steps for your convenience, it's just fine tune. So you're talking about like the pets example. So I think the difference here is just the problem. So I'd still run it for 10 if it was pets. But this is binary classification of probably a very easy problem. That's why we only fit for, that small amount of epochs. Yep, hmm, absolutely. Thank you for that insight. So are we ready to move on a little bit more into the notebook, or are there any more questions about this or fitting in general? Yep. So yeah, so let's take a look here. So right now, this is our unfrozen model. We can see that because all of the parameters are trainable. Now, if I call freeze, we're back to some non-trainable parameters. That was our encoder, so everything up to this head right here. And everything that is the head is now trainable. That's dependent on how you set up your splits. So freeze and unfreeze operates with layer groups. And so you can do learn.freeze and actually it's freeze 2. Yeah, freeze 2 now. and you can freeze up to a particular group. Yeah, let's take a look here. Yeah, unfreeze calls freeze 2 and just resets it to 0. Absolutely. So I believe Sylvain mentioned that it was applicable to other areas when they were doing their testing. Because any this is essentially applicable to anywhere that has transfer learning, I believe. Um, yeah, and so you can freeze your model at whatever it's at, particularly. So in the case of a language model, it would be the pre-trained embeddings we're working off of, fit for a few epochs, unfreeze, and then fit for one. Absolutely. Yep, we can go ahead and do that. So let's, yeah, because we discussed the PI image a little bit, and sort of the how it's all transform based now for the API and your items. Yes. Give me one moment here. What's up? Yeah, yeah, I'm feeling okay. I appreciate it. Actually, sorry, I had to answer something real quick. So, did I miss any questions or something? Yeah, yeah. So the key with doing segmentation is everything is done on a dimension higher. So when we get the output from the model, essentially, instead of it being something like, uh, our probabilities are like zero point 0.1 or zero point 0.3, and, something like this, for instance, where we have two inputs, and so these are their raw probabilities. Instead, we have these essentially channels for the entire batch. And so anything that we want to run with segmentation, yes, thank you. We'd want to run at a dimension higher. On top of that, so uh, Raymond just posted the old lesson, which we can go look at that. So let's go back into here. So I'm sure this will come up whenever we actually do, segmentation in the class. But as we have the void function here, uh, we can create a custom accuracy function that goes through and grabs the accuracy, which is all that this is doing right here. Yeah, exactly. And Absolutely. And then one thing you'll notice that's probably a little different here. So we have our argmax, which, if you're familiar with classification, that looks very familiar to you. We have to pass in a custom dimension here to deal with the fact of how our outputs are a bunch of these segmentation masks. And so that's extremely important if you're trying to convert, various classification metrics and loss functions into something usable by segmentation. Can you repeat that one more time? Sorry. Yes, you can. Um, yeah, so like if we didn't have the void class, we could do just metrics equals accuracy. I believe so. What was the question again? Sorry. So, yeah. Yes, it's cross entropy loss by default. And it uses this dimension one for the axes. Not to get rid of the void, just to deal with the fact of how our y's are expected to be output. So, yeah, there's 32 classes, I believe. And so if we wanted to use the generic accuracy here, if we look at the doc string for accuracy, we expect an input and a target and some axis. This is where I was saying that axis is very important. For regular, we can use -1, but here we need it to be a dimension higher, actually 2 dimensions higher. So we'd want the axis to be 1, which, yes, it uses, I believe accuracy uses argmax for its decision. Yes, so if we just go ahead and bring this over real quick, I'd go ahead and point to actually, yeah, I'd go ahead and open the GitHub, but the links don't really work too well in Colab because we have to right click and source. But if we look at accuracy real quick, you can see that we call the argmax at whatever dimension we choose as the axis. Hmm. So to kind of hit on that a little bit, so there was the whole like image woof competition and whatnot, and there's all these new optimizers in the library, including like for instance Ranger. Um, a lot of it's based on papers where they explored a lot of data sets and saw what generally worked better as a whole. So, yeah, yes, and even then, various loss functions do have experimentation. Like, we have cross entropy loss flat, but also in the course, I believe it was one of the part twos, Jeremy introduced label smoothing cross entropy, which, in my personal research, I found label smoothing to increase accuracy in a lot of cases, sometimes dramatically. Classification. It's another classification metric or loss function. That's about what I do. Well, it does, but it doesn't, because if you want to run .py files where you run and test them, all you have to do is something like bash python 3 my script.py, and then as long as it's in your content right here, it'll go ahead and run it. It I'm mostly going back to how we did Image Wolf, because that what competition was basically running through optimizers, running through different techniques, and trying to see what worked and what didn't. For that competition, before Jeremy changed the leaderboard or the data set, we averaged about 5 times and sort of looked at the standard deviation as well as the mean for how the model performed. Absolutely. Oh, wow. Yeah, I like it a lot. Wow. Very nice find. So, we can kind of mention this again because I think we talked about it a little bit, but in general, Jeremy says overfitting a little is okay. Um, the main thing that you kind of want to watch for is that your training loss and validation loss are both decreasing, and your metric is improving. So long as those three are happening, you're doing good. And then if you're really worried about it, you could have a separate test set that you check on to see how well it generalizes. Or even with labels. You could do label test sets, which I'll mention, are a lot easier to do in fastai 2. Oh, yes. If it has a label, it'll use it. So that's with the test data loader, which I imagine we'll probably get into next class or in a future class, I imagine. Um, but yeah, you can build labeled test sets on the fly. Absolutely, and that's, looking at the confusion matrix after everything's all done and seeing sort of, part of that is understanding what your data set is doing and how your data set works. And the other part is exploring what do you do after it's done training. Exactly. Or like, I was dealing with this a few days ago with a friend. He was getting 99% accuracy on a data set, but that data set had like 5 million of class A and 50,000 of class B. That 1% was class B that was just basically getting ignored. Uh, for that, I will post Rachel's wonderful article on how and why to create a good validation set. And she goes over exactly some of those points. How do you build a good validation set when is just, using a random sample not good? And how do you go about fixing some of those issues? Yep. All right. So I guess we will continue down the notebook then. As Jeremy mentioned, all the API is kind of built the same. So segmentation data loaders looks kind of similar. We pass in some file names, a way to label. In our case, for segmentation, we can also pass in some codes that correspond to the various pixel classes in our segmentation masks. But overall, it looks all kind of the same here. And then if we go over to text, it's also very similar there in the sense of with the IMDb data set, we have a bunch of folders that have all of our text data. And so we can do, a text data loaders from folder, pass in a path, and pass in what we want our validation set to be. So, this high level API, the whole goal of it was to have everything be similar. So that's why, the data block API is really, really nice because everything is in a block format. And so if you want multiple blocks added on, you can do so, which when we looked earlier, we had the data block API when we were calling uh, the image data loaders. So I'll bring that up again. So like, for instance, we have this data block here where we have our inputs and our outputs. And if we wanted to say have a model that had 3 inputs or 2 inputs and 1 output, we could also just put image block and then just specify that our number of inputs is 2. And that's all that you really majorly have to change with this API to now have a two image input, one category output. And all of the other bits and pieces from the data loaders are all built the same way, with the exception of tabular, but I know that's being worked on. Well, that could be like Siamese, where you have image A, image B, and then you have same or not. Hey, Jeremy. Yeah, we're not 100% sure who the host is at the moment. Um, and so there we go. Jeremy's the host now. So we weren't able to record it, so I've got it recording on my recording software, and I'll just post it to a private YouTube link that I'll share in the forums. Yeah, sure. Um, no, absolutely not. So I'll go ahead and stop the sharing, and you can do whatever you like.